This video is about rational expressions. Let's talk about rational expressions. What is a rational expression? An expression that is a fraction. And all of our fraction rules still apply. So let's look at simplifying some basic fractions. The first fraction we're going to look at is 15 over 75. We could put this in our calculator. Our calculator is going to reduce it to 1 over 5. That's because 15 is 3 times 5, and 75 is 3 times 5 times 5. So we have 3 over 5, which cancels to 1, 5 over 5, which cancels to 1. We leave that 1 in the numerator, and we get 1/5. When we look at this fraction, 17 over 7, why don't the 7s cancel? In the last one, we had 3 over 3, and that canceled. Well, here, the 7s are not factors. We can only ever cancel out things that are exactly the same if they are factors. So we need to break down the fractions to show the factors, and then we can cancel. So another example of that would look like this: 36x squared over 75x to the fourth. I've completely factored the numerator, completely factored the denominator. That's called prime factorization. Now, anything that is exactly the same can cancel out. So we have 3 over 3. That can cancel. I can't cancel that 3 again because it's already been used. So now I can cancel out this x and this x and this x and this x. That means when I reduce this fraction, I'll multiply everything back together and I'll get 12 over 25x squared. Since we broke down the numbers into their prime factorizations, factors, we can cancel them. All right, let's make it a little bit more complicated. Here we have binomial factors. So we've been working on factoring quadratics and polynomials, and here we're going to do the same thing. This example already has it factored for you. So I have 4 times the factor of x plus 3. This factor is exactly the same as this factor in the denominator, so they can cancel, and I can be left with 4 over x minus 7. Now, we do have to state our restrictions, and x cannot be -3 or 7. Let's look at another example. In this example, we don't have it already factored, so we're going to factor it. So our numerator I factored with difference of squares to x plus 3 and x minus 3 over x minus 3. Now that both the numerator and denominator are factored, now I can cancel. I cannot cancel until we factor. Let's look at one more example. Here we started with x squared plus 7x over x squared. So I factored the numerator, there was a GCF, and I split the denominator up into the two factors x times x. We now have an x and an x that cancels. I am left with then x plus 7 over x. We are not able to cancel out these two x's. This x and this x cannot cancel. That would be like canceling out when we had 17 over 7. In the numerator, that x is not a factor, so I cannot cancel it. So our final answer, x plus 7 over x. So with fractions, we do have to state our restrictions. Restrictions are something that are just not allowed. And we have a lot of restrictions just in life. Like you can't drive a car until you're 16. You're not allowed to get your real estate license until you're 18. All sorts of restrictions. Not allowed to go in that building because you don't have access, whatever. In math, we have a lot of restrictions, especially when it comes to fractions. And a big one is that we are not allowed to have zeros in our denominator. We're also not allowed to have radicals in our denominator or imaginary numbers in our denominator. And this lesson is going to focus on those zeros in the denominator. So once we've reduced our fraction by canceling out any factors, we also need to state our restrictions. So the first thing that we'll always want to do is to factor. So here I factored the numerator by add multiply. I factored the denominator by difference of squares. We can see that we would cancel out the x plus 2 in the numerator and the x plus 2 in the denominator since those factors are the same. Our final answer would be x minus 6 over x minus 2. Now we have to go back and state our restrictions. Because we're not allowed to have 0 in the denominator, we need to figure out what x, if I plugged it in here, would give me 0, and what x, if I plugged it in here, would also give me 0. There's going to be 2 restrictions for this x value. So I can do a little equation, and I'm going to say, hey, let that factor equal 0. I'm going to minus 2 from both sides, and I get x is equal to negative 2. So if x is negative 2, then it's going to give me 0, and we cannot have that in the denominator. So we're going to say x cannot equal negative 2. Now we'll do the second factor in the denominator. X minus 2 is equal to 0. I'm going to solve that by adding 2. And x also is not allowed to equal positive 2 in this denominator. The numerator is allowed to be 0. That is okay in math. So I don't need to worry about that x minus 6. Don't even need to think about it. I only think about the denominator. Let's take a look at another example. So here, the numerator did not need to be factored since it was already just one term. In the denominator, we had a GCF followed by add multiply. So now I have 3 factors in the denominator. I have 4x, x plus 4, and then x minus 2. There's nothing to cancel out here. All I need to do is state my restrictions. So if I have 4x equals to 0, I'm going to divide both sides by 4, and we get x is equal to 0. So now we know x cannot equal 0. We're going to do the second denominator factor. So we're going to set that equal to 0, and we are going to find out that x cannot equal negative 4. And then I kind of ran out of room, so I'm going to move over here. I'm going to add 2 to both sides and find my third restriction. So I have 1 restriction for each of the factors in my denominator. So our final answer, since nothing would cancel or simplify, we would say that x cannot equal 2, 0, or negative 4. Those are my restrictions. There's some examples below. Why don't you try those out?